Greetings again everyone, welcome back to my channel. Here we have another algebraic exponential equation that we are going to solve. So here we have 9 to the power of x plus 1 minus 9 to the power of x minus 1 is equal to 20, and we are given to find the value of x. Now if you like, you can pause this video and see if you can solve this one on your own. If not, let us go ahead and do this one together. So I'll write my solutions down below here. Also check out my playlist to see how we simplify and solve other algebraic exponential equations. So our equation is that we have 9 to the power of x plus 1 minus 9 to the power of x minus 1 is equal to 20, and we are going to find the value of x. Now to start solving x, we can do a little simplification where we have the exponents x plus 1, and x plus 1 can be simplified as x plus in bracket 2 minus 1, and then we rewrite 9 to the power of x minus 1, and that's all equal to 20. And now it gets a little interesting from here, as we will be using our math laws, in this case the law of indices, where we have a to the power of m plus n is the same as saying a to the power of m times a to the power of n. So we would have the same base with two different powers. This means that we can simplify our equation as 9 to the power of x. We can keep back the negative 1 with the x times 9 to the power of 2, or 9 squared. And then we continue by subtracting 9 to the power of x minus 1. And we have all of that equal to 20. Now if you look closely, this simplification allows us to have 9 to the power of x minus 1 twice. This means that we can factor out 9 to the power of x minus 1 as 9 to the power of x minus 1 in bracket 9 squared minus. We know that if we factor out 9 to the power of x minus 1, that will give us 1, and we close our bracket and have all of that equal to 20. So just to write out what we have here in the bracket a bit further, we have 9 to the power of x minus 1, and in bracket we have 9 squared minus 1. 9 squared is just 81, and that's 81 minus 1, and that's all equal to 20. So then this means that we have 9 to the power of x minus 1, and in our brackets we would have 81 minus 1, and 81 minus 1 gives us 80, and so we have all of that equals to 20. And now we can divide both sides by 80, so 80 will be cancelled out on the left, and on the right we would have 20 over 80, and 20 over 80 gives us 1/4. So we would have 9 to the power of x minus 1 is equal to 1/4. Or we could say a quarter, so 20 divided by 80 gives us a quarter. Now if we look at a quarter, we could actually use our index law here. So we would have 1 over a is the same as saying a to the power of negative 1. Now from here onwards, we'll be using our logarithm to solve for the value of x. So then our equation could be written as log 9 to the power of x minus 1 is equal to log 4 to the power of negative 1. And then we can rewrite this again using this logarithm rule, where we have log x to the power of y is equal to y log x. This means that we take the index x minus 1 and write our equation as x minus 1 log 9 is equal to negative 1 log 4. And we know that 4 is the same as 2 squared. And please take note of this, as we'll be using this as we go along. So we said that 4 can be simplified as 2 squared, and over here we have 9, and 9 can be simplified as 3 squared. So just remember to please take note of these. Now moving along, we divide both sides by log 9 to cancel out the log 9 on the left, and on the right we will have negative 1 log 4 over log 9. So now that we have x minus 1 is equal to negative 1 log, and we said that 4 is simplified as 2 squared, so we have negative 1 log 2 squared over, we said that 9 can be simplified as 3 squared, so we have negative 1 log 2 squared over log 3 squared. And so then this equation could be rewritten as negative 2 log 2 over 2 log 3. So in simplifying our equation, we can cancel out 2. So 2 into negative 2 is going to give us negative 1. So that means that x minus 1 will equal negative log 2 over log 3. And now we can solve for x by adding 1 on both sides of the equation. So 1 will be cancelled out on the left, and on the right we would have log 2 over log 3 plus 1. So x therefore equals, we'll put in our negative sign, so we just not to forget our negatives. So x equals negative log 2 over log 3 plus 1. Now this can be said to be the final solution of x, but we can simplify this a bit further. So we could use this logarithm rule where we have log x over log y is equal to log base y of x. So we're just going to use this rule here to simplify for the solution of x. So that means that x is equal to negative, let's not forget that, negative log base 3 of 2 plus 1. And now this is the final solution of x. Now let's see if we can verify this solution. So we said that x is equal to log base 3 of 2 plus 1. And let's not forget our negative. So that's negative log base 3 of 2 plus 1. So the equation that we had was that 9 to the power of x plus 1 minus 9 to the power of x minus 1 is equal to 20. So to verify the solution of x, we will plug in the value of x into our equation and see if it evaluates as true. So that means we'll have 9 to the power of negative log base 3 of 2 plus 1. And we will close our brackets, and then we would have plus 1 again. And we would have minus 9, and we have it to the same exponent as negative log base 3 of 2 plus 1, and then we subtract 1. And that's all equal to 20. Now we can actually remove the brackets and add our exponents. So 1 plus 1 gives us 2, so we'd have 9 to the power of negative log base 3 of 2 plus 2. And we come again and we say minus 9 to the power of negative log base 3 of 2. And since we have 1 minus 1, we could just cancel them out and leave our exponents as that. And we have all of that equals to 20. And then here now we can apply the index law that we looked at before, where we say that if we have a to the power of m plus n, it means that this can be simplified as a to the power of m times a to the power of n. So when we have the same base with different powers, we just simply add them. And now in applying this algebraic rule, it means that we would have 9 to the power of negative log base 3 of 2 times, using this rule, we would say times 9 to the power of 2. And then we'd have that minus 9 to the power of negative log base 3 of 2. And then we have all of that equal to 20. Now in simplifying what we have here, we could write 9 as we did before, 3 squared. And we have that in brackets, and we raise that to the power of negative log base 3 of 2. And then we could also say times that by 9 squared is 81. And then we would subtract that by, again, 3. 9 it can be simplified as 3 squared. So we have 3 squared in bracket to the power of negative log base 3 of 2. And we have all of this equal to 20. And now in seeing this, we can apply our index rule, where we would have a to the power of m in bracket raised to another power n is equal to a to the power of m times n. So using this rule here, we could write our equation as 3 to the power of 2 times, or in bracket, negative log base 3 of 2. And so I'm just going to write out my equation following the same procedure here. So we would have our 3 here being raised to the power of 2 in brackets negative log base 3 of 2. And we said again all of this is equal to 20. So I'll be just rewriting all of this by expanding my brackets. So we'd have 3 to the power of negative 2 log base 3 of 2 times what we have here is 81. We have that minus 3 to the power of negative 2 log base 3 of 2. And we said that this all equals to 20. Now we'll be applying our logarithm rule once more, where we said before we have y to the power of log x is the same as log x to the power of y. So then, in applying this rule here, we would therefore have our equation being written as 3 to the power of log base 3 of 2 to the power of negative 2. Then times 81 minus 3 to the power of log base 3 of 2 to the power of negative 2. And we say again all of that's equal to 20. And now we will look at another logarithm rule, where we would have x to the power of log base x of y, and whenever we have the same base, it means that that's equal to y. So we'll be using this rule into our equation. So if we look here, we see that we have the same base. So according to our rule, we say whenever we have the same base, the answer is y. So we rewrite our equation as 2 to the power of negative 2 times 81 minus, again here we have the same thing, so we would just have this being equal to 2 to the power of negative 2. And again we say that that's all equal to 20. Now 2 to the power of negative 2, whenever we have a negative power, it means a reciprocal. So we would have 1 over 2 squared times 81 minus, and we would have the same thing, 1 over 2 squared. And again this all equals 20. So 1 over 2 squared means 1 over 4, as 2 squared is 4. Then we have that times 81 minus 1 over 4 is equal to 20. And now we can multiply across, so we say 1 times 81 is 81, and that's going to be 81 over 4. So we have 81 over 4 minus 1 over 4. And of course that's all equal to 20. Now, as you know, when subtracting fractions with the same denominator, we subtract the numerators. 81 minus 1 is 80, and we rewrite the denominator. So we have 80 over 4 is equal to 20. And we now say 4 into 4 goes 1 time, and 4 into 80 goes 20 times. And now look, there we have it. Our solution for x is now verified. X indeed equals negative log base 3 of 2 plus 1. Now, thank you very much for staying with me until the end. I hope that this was a very informative lesson. If you like this video, please smash that like button, share and subscribe for more math lessons like these. And until then, take care.